You might already have had a go at coding some of the earlier examples of networks. And if you have, then good. You've probably discovered what I'm going to say in this video. And practice is the best way to learn about most things, and especially programming. If you haven't yet tried any coding, here's my advice about starting. First, start with some very simple examples. Let's say a 1 by 2 pixel pattern as shown. Once you have this simple network working, try adding some noise to the patterns and observe when the network can no longer recognize them. Try training the network with noisy examples as well as with perfect ones, and observe whether this improves its performance with other noisy examples that it hasn't seen. If you're not a brilliant programmer, then start this initial network using separate variables for each weights as shown. Once you have this working, change your variables to arrays and use loops to calculate the network parameters. An example of this is shown on the screen. Once you have this working, then you'll be able to expand your network up to any size simply by changing the size of the arrays. A good place to go next is a 2 by 2 or 3 by 3 image. These networks are a good place to start experimenting with different network sizes, particularly the number of hidden layer neurons and the effect this has on network performance and its relationship with the number of patterns that you can store. A 5 by 7 pixel image is a good place to practice character recognition with, and you can store all the letters of the alphabet on this grid. Try a network with between 5 and 15 hidden layer neurons to recognize all 26 letters. For example, 35 inputs from a 5 by 7 grid into 10 hidden layer neurons into 26 output neurons, one for each letter of the alphabet. After this, it's time to move on to real images. A very useful thing to do here is to experiment with the smallest image in which a face is recognizable. You typically find this is about a 40 by 40 grid. Try reducing image sizes in Photoshop or a similar package to experiment and save the resulting file as a raw file. This is also a good place to start experimenting with momentum or other solutions to the local minima problem, as you'll start to see this crop up more and more with more complex problems.